Hello friends, welcome to class 11 lecture on Introduction to NASTRAN. So far in this course we have been seeing various different things on with Patran, which is the preprocessor. So before we get into the post-processing aspect of the analysis and various different types of analysis such as linear static, buckling and vibration and dynamics. So I felt it would be more appropriate for you to learn the basics of NASTRAN before we get into the complex stuff. So in this lecture, so I'll be introducing you to the fundamentals of NASTRAN. What are all the basic inputs and outputs of the to the NASTRAN solver, and what kind of output we are getting from the preprocessor and how it is going into the solver and those kind of stuff. One of the important thing is like whatever the mathematical model which we built up in the Patran, which is the preprocessor, it will be from the preprocessor, it will be fed into the solver for in order for the solver to solve the problem. But the solver reads a type of a set of commands in a text format. That file is called the PDF file, which will be output from the Patran. So we'll just look into all those details in this lecture. So I'll move on to the slides. So first one is the Patran NASTRAN workflow and files. So Patran, as you know, Patran is both the preprocessor and the post-processor. Pre-processing is used for importing the geometry, creating the geometry, and then building up the finite element mesh, applying the boundary conditions, loads, and we are creating the material properties, element properties, and finally we are sending the model whatever we have built to the solver to analyze. And once the solver analyzes the problem and then it sends back to the post processor Patran, or we are manually importing it in Patran for our colorful stress plots, deformation plots, and we will be seeing the post processing options in the next lecture, class 8. So just at the minute for your understanding. So whatever the problem the finite element solver analyzes and solves it, so we import those results back into the Patran for the visualization purpose, for the plots purpose. So whatever the finite element model, whatever which is being built up by the user, will be sent to the solver first. So what is the mode of communicating between the this Patron preprocessor and the solver? It is through a type of file called .bdf file. .bdf file is nothing but it opens with your text pad, notepad. It's like a text file which has a set of commands. What actually Patron does is whatever the model, whatever we are building up, whatever we could see on the visualize on the screen, Patron screen, it would write the same model in a command format. I will show you examples in a minute, like at the moment. So just for your understanding, it will write the physical model into a set of commands which can be edited using a text pad, notepad or word pad, but you should note the commands, you should note the format of the commands. And expert user in Patran and NASTRAN will not go directly to Patran, will directly open up this file and edit the uh, parameters whatever he wants. So in that way, Patran and NASTRAN provides a flexibility to the user that anything can be edited within the textpad file. So, and then the NASTRAN reads the textpad file, it solves the problem, generates the results. While the NASTRAN solves the problem, it generates some support files called F04, F06 and log file. Log file, as the name indicate, it is just the log, what kind of memory has been used and how much time the job has taken to solve and those kind of stuff. And F04 is a binary file, and F06 is the, again, it's a type of file that NASTRAN produces. It, what it does is it prints all the element stresses and element loads, reaction loads in this file F06. It is one of the important files, same as BDF file. BDF file is the file, I repeat here, like it started with the BDF file. BDF file is the file that would has the, that contains the, I would say like this, that contains the physical model, whatever model, loads, boundary conditions, properties, and everything. Like when I say model, that not only includes the geometry and mesh, but also it includes boundary condition, loads, and the properties, both element and material properties. All the entire model or the entire finite element represented using a set of commands, that is the BDF file. It can be opened using your notepad, textpad, wordpad, and Word document, and etc. And then it goes into the NASTRAN. NASTRAN solves the problem, and then the results file F06 file is the your results file. It prints all the results, displacements, element stresses, nodal stresses, whatever the output requested by the user. And then from the solver, we should have some option just to import back the results into the um, which is post processor, which is obviously Patran, just for our visualization purpose, in order to take the colorful deformation plot or stress plot or generate these reporting type of format plots. This is done using two types of file, one is XDB and OP2. I'll be explaining the difference between them in the next lecture, post processing. But at the minute, please bear it in mind that from NASTRAN we get these two files. NASTRAN generates these three files, at the same time it generates these either one of them. It depends on the user what he requests in the BDF file. If he wants to generate XDB, then XDB will be generated. If he wants to generate OP2, OP2 will be generated. I'll talk about the difference in the next lecture, as I mentioned. So this file, these two file is a binary file. Even if you open it in the WordPad or TextPad, it won't be, you won't be able to read it. But when you import that into the Patran, it will generate all the plots and stress plots and deformation plots and etc. So along with these types of files and the entire Patran and NASTRAN runs, they also generate a few other support file, which is the session file or the journal file, and database file is the model, which is the Patran file, which has the physical finite element model. So this is the summary of the file types and for what they have been used. So whatever I have explained a minute back. So first one is the NASTRAN input file. So NASTRAN input file is nothing but the BDF file. So there are two types of file that contain the finite element model as I explained earlier. So one is the Patran database file, which is the DB file where you can physically visualize the model. You can see the mesh, you can see how you can apply the loads, how you can apply the boundary conditions, and those kind of stuff. And Nastran is the and the Nastran input is the PDF file where the same model can be opened in a text format, text pan, using the text pan, and you can practically see how the model is being converted into a set of commands. So what is the flexibility an user get? So it can be viewed and edited in any text editor, and it can also include comments for if you want to amend any values, you can amend, or if you want to change the loads, you can change. So it provides a complete flexibility for the user to play with, and it also allows to completely change the model. You want to change the element numbering, grid numbering, node numbering, you can change. So you can do anything you want with the mesh just by changing the parameters in the command, NASTRAN command. The entire finite element will be changed. And more importantly, it also very useful in debugging a model. Suppose when there is a after you solve the go back go back to the previous after you submit the PDF file, which is the Nastran input file to the Nastran, and once the Nastran solves the problem, and once it generates the results, and then suppose a user realizes that this is not the result which he was expecting, or if the model didn't behave the way he was expecting, then he could always, instead of going to Patran, and if it is a very big geometry, instead of going to Patran and just to see what is happening, what is causing the problem, instead you can go to directly open the PDF file in text editor and see what is creating the problem, or what is there any parameter that is strange, uh, like that is not quite addressed in a way he expected. So you could always play with the PDF file and change the parameters and change the commands, or include a few other things, and then you can submit the job back to the solver. So in that way, Nastran and Patran provides lot of flexibilities compared to various different analysis tools and FE tools available in the market. So NASTRAN Patran has such a very user friendly FE tool. So before we go and look into the example of NASTRAN file, which is the NASTRAN input file PDF file, there are some certain formats of the file, which is the uh, probably it will be called as the sections within the NASTRAN file. One is the NASTRAN statement, and other one is, there are totally 5 sections. The starting with NASTRAN statement, file management section, executive control section, case control section, and bulk data section. So the names might little bit strange, um, but as we move on, you will try to understand. First, I will go and jump into the example and show you. And this is a typical example where typical example of a NASTRAN file, NASTRAN input file, which is the PDF file. You can see it as whatever the finite element model that has been built on the screen, Patran screen, has been converted into a set of commands. And what it does is NASTRAN neatly organizes these commands, categorizes and neatly organizes and puts in a piece of text document. Sorry, Patran, when we create, there is an option within the Patran that is called as creating the NASTRAN input file. When you create it, this PDF file will be generated. So during the process of generation of this PDF file, the commands will be neatly organized and categorized and will be put together. So the first section is the, we don't have the NASTRAN statement. So NASTRAN statement and these are all the optional sections, and every PDF file will definitely have these three sections, but it's not necessary that the PDF file will contain this NASTRAN statement and file management section. So NASTRAN statement, it is a set of commands that is used to modify the system defaults, and then they're mostly not needed in most of the analysis. When you say system default, it might be the system buffer memory or the temporary memory and those kind of user memory and those kind of command format statement in order to change the buffer memory and those kind of for the runtime memory and those kind of stuff. And then moving on to the file management, next one is the file management section. File management section, what it does is it allocates files, controls restarts and database operations. So there are some operations to allocate, files and controlling the database and database options. So this, I think this again file management section is an optional section. But moving on to the executive control section, which is the third one, third part of the NASTRAN input file. uh, Executive control section contains the solution type and time allowed and the program modifications and system diagnostics, sorry. And then the case control section. Case control section will have all the requested outputs, what kind of file you are requesting, whether it is a XDB file or OP2 file. And then it also selects the bulk data entries such as loading constraints to be used. And then bulk data section will have the complete model definition, which is the finite element model, quad element, tri element, RVE2, MPC, all the whatever elements you created within Patran. And then it also has the loadings, boundary conditions, properties, etc. So you can see over here the executive control sections. It is here. So usually we don't have the file management section and the NASTRAN statement. So executive control statement will tell you what type of analysis that is being carried out. In this case, it is a linear static analysis. And then the case control section will control the load cases. What are all the load cases you create will be listed here. And then what kind of output you are requesting for that particular load case will also be shown here. And then the bulk data section. Bulk data section is the complete finite element. So yeah, it's not, yeah, just this snapshot probably will discuss in the couple of slides. So there are some formats of the bulk data entries, so we'll come later. I will open here. And so this is solution 101 on linear static analysis. So this is the NASTRAN executable control section, And then what we are moving on to is the case control section. Case control is, in this case, it is an default load case. There is no special load case. So case control section is the section that will show you how many different load cases are there, and what load cases are there, and what kind of outputs have been requested for that particular load case. And then you, from the begin bulk, it will be bulk data section. Bulk data section will suppose be there are, these are all a set of commands. This, the entire thing is a set of commands that that your user could easily understand, because they have a set of format using which it can, you can easily understand. And this is a bulk data section, which is mainly the finite element mesh. You have a shell element, you have a quad element, and then you can see the equivalent commands for those elements have been printed in the PDF. Towards the end of the file, there will be load, there will be single point constraints, there will be constraints defined, or sometimes there will be a load defined towards the end of the file. So this is typically NASTRAN input BDF file.